Section 3.4 and 3.5, Properties and Graphs of Rational Functions, Part 2. Recall that in Part 1 we found domain, and I also want to remind you why we're doing all these things: domain, asymptote, holds, intercepts, behavior, and checking if graph crosses horizontal asymptote. At the end of this lesson, we're going to put all that together and you're going to be able to graph these complicated rational functions. So let's take a look at asymptotes. Now, vertical asymptotes we've done before, so this is just a little bit of a review. If you recall, a vertical asymptote happens where the denominator equals 0. And I'm just going to use part A and B of the example we already did in the first part of this lesson, because we already solved we already found where the denominator equals 0. So in part A, we found that the denominator equals 0 at x equals a half. And this is where I'm looking at. I'm just going to highlight it so you can follow along. That's where I'm looking at. So since the denominator equals 0, where x equals a half, that is our vertical asymptote. Okay. For part A. Now remember that vertical asymptotes are equations of lines. We can't just write a half, because when half is a number, it is not a line. So we must write x equals a half. For part B, we're doing the same thing. We already found where the denominator equals 0. I'm just going to highlight that so you can see. And that is at x equals 2 and x equals 3. And those become the equation of our line for the vertical asymptotes. Now let's take a look at horizontal asymptotes. Horizontal asymptotes are a little bit more complicated. What we need to do is we need to figure out what f of x is approaching as x is getting infinitely large and infinitely small. And if we get a number, say b, if f of x approaches b, then y equals b becomes the equation of our horizontal asymptote. Now, before we do an example, there's two concepts I need you to understand. The first one is that any number over an infinitely huge number or infinitely small number is always going to equal to 0. What do I mean? Well, this is what I'm looking at right now. Okay, what do I mean? Well, let's say you have, I don't know, $5. Let's say you have $5. And you have infinite amount of friends, and you say, you know, I'm feeling so generous, I'm going to divide my $5 amongst my infinite friends. Okay? Now, if you divide your $5 amongst your infinite friends, how much are they each going to get? They're practically going to get 0, right? So as that denominator gets larger and larger, infinitely smaller, you're going to approach 0. Now let's take a look at the second fraction. If you have a number and you're dividing it by a number really close to 0, then you're going to hit a huge number. And an easy way to check that is grab your calculator and divide 3 divided by 0.01, and then do 3 divided by 0.00001, and then do 3 divided by 0.00001. The more zeros you add, you're going to see that the larger your fraction gets, and it gets closer to positive infinity. Of course, if you're dealing with positive numbers. If you're dealing with negative numbers, then you're going to get closer to negative infinity. Okay, so keep those two fractions in mind, because we're going to use them to find horizontal asymptotes. Now let's take a look at our first example. So part A, f of x equals 5x over 2x minus 1. Notice that we're still doing the same example. Okay, and I did outline steps for you because, like I said, horizontal asymptotes are a little bit more complicated to find than the other asymptotes. First, divide every term in both the denominator and numerator by the variable with the highest power in the denominator. And we do this just to simplify. I mean, we could plug in a huge number now, but just to simplify a little bit. Let's see what happens. And for those of you going on to calculus, you will have to do this in your calculus class. Okay, so the variable in the denominator, and right now I'm only doing part A, so we're only concentrating on part A right now. The variable with the highest exponent in the denominator is x. And that is why now we're going to divide every single term in the numerator and the denominator by x. Okay. Now, if we divide 5x over x, 2x over x, and 1 over x, and then simplify, we get 5 over 2 minus 1 over x. Okay, step 2. Find what f of x is approaching as x approaches plus and minus infinity. Okay, so first and again, I'm only doing part A right now. I'm not even in part B. Okay, so we're first going to plug in x approaches positive infinity. Now remember, infinity is not a number, so I can't really plug it in. When you go on to calculus, you're doing all this in your head. But because you haven't seen it before and these are your notes, we're actually going to plug it in. Okay, so let's go ahead and plug in our infinity. So if we plug in, we get 1 over infinity, and it's highlighted so you could see where I'm at. Do you remember what I said 1 over infinity is? It's up here if you don't remember. Any number over plus or minus infinity equals 0. So we can simplify that and we get 0 for 1 over infinity. Okay, so that gives us 5 over 2 minus 0, which gives us 5 over 2. And then we also do the same thing for x approaches negative infinity. Okay, so that also gives us 5 over 2 plus 0, and that gives us 5 halves. So notice that as x approaches plus or minus infinity, we get a number, mainly 5 over 2. That means that our horizontal asymptote is 5 over 2, and we'll get to that in the next step. So hence, as x approaches plus or minus infinity, f of x is equal to 5, or if f of x approaches 5 over 2. Okay, and again, that's going to be our horizontal asymptote. Okay, so let's take a look at example B. Okay, for example B, notice that our highest exponent is x squared, and that's why I divided everything by x squared and then simplified here. Okay, so now we're ready to plug in our infinity. So if I plug in, and now we're here where I'm highlighting, if I plug in infinity for x, okay, notice that 1 over infinity is 0, 1 over infinity squared is 0, and then in the bottom 5 over infinity is 0, and 6 over infinity squared is 0. That leaves me with 0 minus 0 over 1 minus 0 plus 0, and we get 0. And then for the negative infinity, we're doing the same thing, and we also get 0. Hence, as x approaches plus or minus infinity, f of x approaches 0. So for part B, what is our horizontal asymptote? If you said y equals 0, then you are correct. Okay, so just a little bit to summarize. So for part A, since f of x approaches 5 halves as x approaches plus or minus infinity, the horizontal asymptote of f of x is y equals 5 halves. And then the same thing for B, but in that case, our horizontal asymptote is y equals 0. Now, there is a shortcut to finding the asymptotes. I'm a little bit reluctant to show it because I do want you to show your work for the x approaches plus or minus infinity. And the reason you want to show your work is because that is going to help us graph. So we'll be able to see on the graph, oh, as x gets larger and larger, my graph is getting closer to 5 halves. And if you don't have that, it'll be hard to see that. But I'm going to show you the shortcut just so you can check your work. Make sure you're only using it to check your work. So here we go. If the degree of the numerator is smaller than the degree of the denominator, then horizontal asymptote is y equals 0. And I mean, you can probably see why. Here, let's do this. You can probably see why, because if you think of plugging in positive infinity, just like we did earlier, okay, as x approaches infinity, so you have an infinity on top, so to speak, and an infinity to the fourth power on the bottom. So the bottom is a lot larger than the top, right? Since we have infinity to the fourth. So we get any number over an infinite number if of x approaches 0. Okay, so since the bottom is larger, it's going to grow a lot faster. Our function is going to approach 0. Okay. And then same thing for the negative infinity. So, I mean, you don't have to memorize this. You can make sense of this. And then for if the degree of the numerator is greater than the degree of the denominator, then horizontal asymptote is none. And this is the same concept I was saying above. So, for example, if you think about plugging in x approaching positive plus or minus infinity, what are we going to get? What do you think we're going to get? If you said y approaches positive infinity, you are correct. And hence we have no y. Y must approach a number in order to have a horizontal asymptote. And then think about y. If I plug in infinity to the 8th minus 6, and then on the bottom infinity squared plus 1, the numerator is growing a lot faster. So because it's growing a lot faster, you're approaching an infinite number. Okay, so the last one is, what if the degree of the numerator and the degree of the denominator are exactly the same? Well, if they're exactly the same, it turns out that we're going to approach a number. Okay, and this is, so just if you looked above, this is like our situation in part A. And this is like our situation in part B. Okay, so again, if I go up, in part A, the degree of the numerator and the degree of the denominator are both 1, and hence we got a number 5/2. In part B, we had, where's part B? Here. In part B, we had that the degree of the denominator is higher than the degree of the numerator, and that is why we got 0. As x approaches plus or minus infinity, y approaches 0, and hence our horizontal asymptote was y equals 0. And I will leave oblique asymptotes for part 3 so that I'm not cut right in the middle. And if you have any questions, again, please don't hesitate to email me. Thank you.